Today we're in section 12.5. Put your hands together for the final lesson of the year. Okay, very good. Yes, that is something to celebrate, okay? You guys have survived honors pre-algebra. Okay, quiet. Hey, the recording's ticking. It's going. Okay, so, yeah, so that is quite an accomplishment, something you should be very proud of. It's not been easy, but you've risen to that level, and you've done very, very well. All right, so when we're dealing with exponents, we're just going to look at some other rules and properties that we can apply. That involves raising a term that's in parentheses to a power. All right, now you don't have to write any of this down. But basically what that means is whatever that exponent is, it's raising every part of that term to the third power. So that's going to be a to the third power and also b to the third power. So the exponent raises every part of the term to that power. All right, let's see what that looks like in an example. In the example 1, again, the exponent raises 2 to the third power and x to the third power. Here's how I show that. I show it by breaking it up, showing that each individual term is being raised. So I would say 2 to the third power times x to the third power. Again, every term inside the parentheses being raised to the third power. And now, can I evaluate 2 to the third power? Absolutely. 2 to the third power is what? 8. 8. 2 times 2 times 2. 8x to the third. All right. I want you to try the second one. It's a negative, so make sure you put that in parentheses before you evaluate. So negative 5 to the second power times y to the second power gives me 25y to the second power. Who got that right? 25y to the second power. Now, in the last term, there's 3 terms inside the parentheses all connected. So it's 4 to the 5th times x to the 5th times z to the 5th. And I combine them all together to make 1024 x to the 5th, z to the 5th. Again, the exponent outside the parentheses raises every term inside the parentheses to that power. All right, so that's example 1. We feel good about it? Evaluating powers of products? Okay. Now let's do quotients. What does quotient mean?
The answer you get when you multiply.
Finding powers of quotients. Powers of quotients. So now I'm still evaluating each individual term, and I can simplify if the variable is the same. You're going to find that the variables really aren't the same on these examples, though. So really, I'm just distributing or diversifying that 7 into my terms inside the parentheses. All right, so the first one would be, anybody want to take a stab at it? No. M to the 7th over n to the 7th. What do you think about the second one? Negative 3 to the 5th and k to the 5th. Wait, what did I forget on that one? What did I forget?
Negative 3 times
Very good. Negative 3 needs to be in parentheses. If it is not in parentheses in your calculator, it will not calculate correctly. It'll assume that it's negative 3 times positive 3. All right, so you've got to make sure you evaluate that correctly. And yes, we can simplify. Negative 3 to the 5th power is what?
negative 243.
Over k to the 5th. So when I'm using my quotient of powers, I can subtract if the variables are the same. In this case, they're not, so I'm just distributing that exponent throughout every term inside the parentheses. Now you try 2 of your own. Okay, so a squared over 36 and b to the 3rd over c to the 3rd. Did you get it? Okay, so quotient powers, done. in example 3, now I'm looking at finding a power of a power. Yes, that is correct. A power of a power. Now, when I'm looking at this, I do want to show you this slide. Here, let me show you this one. All right, finding a power of a power. Here's what it's saying. You can, when you're taking a power inside the parentheses and raising it to another power, remember, let's take, for example, 2 to the third power. Was that 2 times 3? No, it's 2 times 2 times 2. You're multiplying it by itself. So that's what we're doing here. A to the second power raised to the fourth power, I'm multiplying it by itself 4 times. You see that? So then when I do that, I am essentially adding my exponents to equal a to the 8th power. All right, now there is a faster way. You can multiply your exponents. So if you're taking a power and raising it to a power, you keep the common base and you multiply your exponents. So we're not actually solving anything here, but we're keeping the same base and multiplying our exponents. Here's what it looks like in a problem. Okay, 10 to the third power raised to the third power. Again, that's 10 to the third times 10 to the third times 10 to the third. It's repeating, which is why we multiply our exponents. What would it be? 10 to the, no. We are not evaluating it. Anytime we raise a power to a power, we're not evaluating it. We're keeping our common base and then multiplying our exponents, 10 to the 9th power. What about the second one? P to the negative 20th power. But wait. Use positive exponents. How can I turn the negative 20th power into a positive exponent? Jonathan?
You make it 1 over p to the 20th.
You flip the fraction. Remember, any whole number is over 1, so if I flip the fraction, it now reverses the sign of my exponent, which is exactly what I need. So it's 1 over p to the 20th. Guys, remember that? You see how we're kind of pulling from all these exponent rules that we've learned all year? All right, and now you think this is easy, but it's not really. It's just you've already kind of laid the groundwork for it. All right, so I want you to try a couple. All right, I want you to do these 4. Go ahead and simplify the expression and write your answer using only positive exponents. Okay, so what would the first one be? 2 to the... Yes, 2 to the 12th power. Now remember, you do not evaluate. Anytime you're taking a power, raising to a power, just keep the common base and raise to the power. What about number 2? 1 over 5 to the 4th, because that's 5 to the negative 4th, so we have to switch it. 1 over 5 to the 4th. What about the third one? K to the 18th. What about the fourth one?
1 over 18.
Man, you guys are awesome. 1 over 8 to the 10th. Who got them all right? Okay, great job, guys. We're through example 3. Take a deep breath. The final example. The last example. And it's scientific notation. The world's teeniest, tiniest book. The square pages of this book are about 2.5 times 10 to the negative 3rd power meters on each side. What is the approximate area of one page of this book? Well, we have the expression 2.5 times 10 to the negative 3rd. What power do you think we would raise this to? We're trying to find the area, and it is a square book.
4.
No, 2, 3.
You're raising it to the 2nd power, okay? Because the area of a square is s squared, s times s. So we square this. What does it mean to square it? It means we take every term inside the parentheses and we raise it to the second power. Remember, if I'm raising a power to a power, do I evaluate it? No. I keep the base the same and raise my exponent. Go ahead and now try to evaluate this expression. Okay, what's 2.5 squared?
6.25.
What's 10 to the negative third squared?
10 to the negative 6.
6.25 times 10 to the negative 6 square meters. Or meters squared. That would be fine too. Okay, so taking an expression, you have a section like this on your homework tonight. So just make sure you raise each term inside the parentheses to that power. And if you understand that, that's everything you need to know for your last pre-algebra lesson of the year.